Brad started his career in conservation working in the Hoosier National Forest on migratory songbirds as an undergrad at Indiana University. He worked throughout parts of the US and Canada before landing in Southwest Florida, working on Sanibel Island, doing wetland restoration and land management. He began working for the Nature Conservancy in 2010 as the Director of Land Management in the New Jersey chapter, before transferring to his current position here as the Lower Wabash and Wetlands Program Director for Indiana. Hopefully he'll explain what that means himself. His efforts are focused on expanding floodplain protection, improving water quality, and improving habitat for migratory birds. So please help me welcome Mr. Brad Beason.
All right, thanks everybody. Thanks for having me. I'll pull this up here. All right, so I'm going to talk to you a bit about the work that I'm directly involved in, but more broadly, the work that Nature Conservancy is involved in Indiana to revive our rivers. Improve fresh water in our river systems is important for many of the species that we're concerned about, mussels and fish, and I'll talk to you a little bit more about that here in a minute. First, let me tell you a little bit more about the Nature Conservancy. So we are a not-for-profit organization. We are the largest conservation organization in the world. We operate in all 50 states and in about 33 countries worldwide. About anywhere from 3,800 to 4,000 employees working for the Nature Conservancy currently. As I said, my work is mostly focused here in Indiana, a little bit over on the Illinois side of the Wabash River. And let's talk about the Wabash River. So a lot of the freshwater work that we do is within the Wabash River watershed. We also have projects in Blue River over in Harrison County, and also in the Western Lake Erie Basin up there by Fort Wayne. But the majority of the bulk of our work is in the Wabash Basin, and there's a reason for that. One, it covers much of Indiana, as you can see from this photograph. That blue area is the Wabash River Basin. So that's all the area that drains out and comes right past here, out on into the Ohio River. So, a couple of interesting things to note about the Wabash River, and this starts to get to the reason why we're involved in trying to improve water quality within this basin. It's the longest undammed river east of the Mississippi. The undammed portion of the Wabash is over 400 miles in length. The entire river is about 503 miles, starting in Ohio there. You can see a little thumb there going just over into central Ohio. And another important attribute about the Wabash River is it's still largely connected to its floodplain over long stretches of the river. The river was never fully developed for navigation. So that's part of the reason why we do not have extensive levee systems, and we do not have dams on the main channel of the river itself. So all of those things are going to play into the story that I'm going to talk to you about this evening. First off, let's talk about fresh water. Well, let's talk about water in general. So this is the Earth, and it's the Earth with all the water taken up off of it and rolled up into a ball. And that's what you see there. Pointer here. This big ball that you see here. All the world's water rolled up into a ball. And that seems like, how can that be? Because the Earth's surface is 3/4 covered in water. But if you consider that the average depth of the ocean is less than 2 miles deep, and the Earth is 7,900 miles across at the equator, it's a relatively thin layer of water that's covering our surface. So that's all the oceans, the rivers, the lakes, all rolled up into one. Then you think about, well, 97% of that water is salt water. this ball here is all of our fresh water on the earth. So we're getting increasingly small amounts of water that we have to deal with at any given time. And if you take from that and you take out all of the glaciers and ice caps, you get this little tiny ball that is completely covered by that cursor there. So that's about the size and diameter of the metro area of Atlanta, rolled up into a ball. So that's all the water, surface water on the earth, all the rivers, all the lakes, all rolled up into a ball. When you look at it from that perspective, it's a rare commodity. We don't have a whole lot available to us, so it behooves us to take care of it. So there's a whole lot of demand for that water. At the same time, there's my graphics. So I just took a snapshot of this this morning from the internet. Current world population, it's probably gone up by about 20 million since then. At 7.7 billion people, we're projected to be up to 9 billion by the year 2050. All of those people, all of us, need water to drink, and of course water consumption in many other forms in manufacturing and agriculture and so forth. All of that increasing demand on a finite resource. So people, of course, also need things to eat. We all like to eat. And that too has been changing over the decades and trying to meet that demand by that increasing population size. So if you take a look at this graphic, it starts off in the 1970s there in the upper left, then jumps to the 80s, and then down on the bottom left in the 90s and the 2000s. And as you go to the yellow, orange to red, it's an intensification of corn and soybean growth, acres essentially. So that's county by county. And so what that's indicating is the percentage of that county's land area that's dedicated to growing corn and soybeans. So what we see as time has gone by is we see less corn and soybeans being grown, a little bit less over, there's more corn and soybeans being grown, but it's being grown increasingly in an intense area here in the Midwest. So it's an intensification of the area where we're getting our corn, the majority of our calories and protein from in corn and soybeans. And so that has impacts. And many of you probably heard about this impact. It's been getting a lot of press. This is called the Gulf of Mexico Dead Zone, or the hypoxic zone. So this is an area off the coast of Louisiana. Here is where the Mississippi comes in to the Gulf of Mexico. So the Mississippi comes in and the Gulf currents carry the water of the Mississippi off to the west towards Texas. And what happens annually in the summertime, you get a large algae bloom in the Gulf of Mexico. And that algae bloom grows very rapidly and in very large quantities, and then it dies off. When that algae bloom dies, the decomposition of that algae sucks all of the oxygen out of the water. And so, hence the name dead zone. There's no oxygen in the water, so organisms that can't get out of that space, and that's usually roughly varies from the size of Massachusetts to New Jersey, depending on the year, in size, they're going to die. So it's a large dead zone in the Gulf of Mexico. Of course, this is a concern ecologically. It's also a concern financially for people who make a living on seafood in the Gulf of Mexico. Louisiana is second only to Alaska in terms of pounds of seafood harvested. So there's a big impact. And what is believed to be driving this are excess nutrients coming out down the Mississippi and into the Gulf of Mexico and fueling algae blooms. In saltwater systems, the typical limiting nutrient for saltwater systems for algae blooms is phosphorus. In freshwater systems, it's nitrogen. And so those two nutrients are instrumental in growing the high-yielding crops that we all depend on for abundant, cheap food. What we're doing here in the Midwest is directly impacting not only our freshwater systems all along the way, but it's also impacting areas in the Gulf of Mexico. And so this again, so this is the yellow area, colored area here is the Mississippi River Basin. The black outlined area there is the Wabash River nested within the larger Mississippi Basin. And then this is divided up into smaller basins. These are about the size of the East Fork of the White River, West Fork White River, Patoka River, roughly about that size basin. And what this is illustrating is this map looks very much like the map of corn intensification. And so this is indicating the amount of nitrogen, this particular map is showing nitrogen, that is being exported out of each of those smaller watersheds. So as you go from the yellows to orange to red, it's an increasing amount of nitrogen export being lost out of that river system on a regular basis. So you can see again, the Wabash River is right here in the heart of it, right in the heart of that corn belt. So how does the Wabash River look compared to other river systems? Well, so this is total nitrogen contributions to the Gulf of Mexico, nitrogen and phosphorus. And the Wabash River is actually contributing 20% of the total. So we're the largest single contributor of nitrogen and phosphorus to the Gulf of Mexico in the Wabash River. So these are all similar sized river basins to the Wabash. Second is the Illinois River, and then the Iowa River. So Indiana, Illinois, Iowa, Corn Belt. There's a reason why the Wabash River is number one. And it also happens to be the same reason why the Nature Conservancy has been interested in protecting, improving water quality, I should say, in the Wabash River for at least 2 decades now.
Why doesn't the Mississippi River show up there, or do each of these basins feed the Mississippi?
Right, so each of these are a sub-basin within the Mississippi Basin.
Okay.
Yeah.
So the total is the Mississippi Basin.
That's right. Yep. All right, so I've been harping a lot about the Corn Belt, and agriculture is certainly not the only culprit in this. There are many of our cities, most of our cities, have a lot of issues with combined sewer overflow. So that's where you get intense rainfall events, or even in some cases, even a half-inch rainfall event will overwhelm their stormwater systems. Those stormwater systems flow into their wastewater treatment plants. They overflow those things, and then you have raw sewage that's going into our river systems. A lot of our cities, most of our major cities have had those issues and have been dealing with those issues over the last 5-10 years in particular. A lot of money is being spent to retrofit and try to eliminate those situations, or at least to minimize them. So a lot of money is being invested on that end. Of course, septic systems are another contributor of excess nutrients to our systems. So lest you think I'm just picking on agriculture, there's a lot of different players in this field, or what we call non-point pollution sources. But I would say too that in order to answer that question, we need to take a look at our history, because the problem started before we started growing corn in the Midwest. And it started when we started to lose this habitat. So this is shallow emergent marsh habitat. And in the upper Mississippi River Basin alone, so that would be Iowa, Minnesota, Illinois, Indiana, In that part alone of the Mississippi Basin, there was an estimated 51 million acres of this habitat in the year 1600. We now have about 500,000 acres of this habitat. And so where did that habitat go? It started disappearing when this animal started disappearing. So fur trappers came into the Midwest and they began trapping beaver. And that habitat was created by beaver, by and large. And so what that habitat meant for our river systems was a tremendous capacity to store water on the landscape and release it slowly down our river systems rather than sending it all down in big pulses when we have rainfall events. If you consider those shallow marshes were, a foot, 2 foot deep, that was equivalent to 12, 24 inches of rainfall storage in that area. That was a tremendous volume of water that could be stored on the landscape. When the beaver started going, those dams failed. There weren't beaver to rebuild them, so we started losing capacity to store water. You're going to hear me keep saying that phrase, a loss of capacity to store water. So what are some of the other factors? Well, the land conversion that followed with settlement. So if I were to ask you all in 1900 what percentage of Indiana, well, let me step back. Indiana pre-settlement time was about 90%, I've heard as low as 80, but 90% forested. In 1900, what would you guess? It was 1%. Well, I've heard anywhere from 1 to 4%. I put the high end up here. We had nearly completely deforested the state in the year 1900. By the year 1900. This is a picture from Morgan Monroe State Forest. You can see what some of the impacts of that were. We had soils exposed that were highly erodible soils. They were very poor for farming. But by and large, that's what the land was cleared for. It was cleared for homesteading. And people couldn't get enough land for homestead. And so you consider in a matter of about 100 years, with axes and oxen, they almost completely cleared the state of forests and trees. It's an amazing accomplishment. But it had a lot of big impacts. And if you think about, again, in terms of water storage capacity on the landscape, if you consider that a single mature tree can store about 100 gallons of water just on its surface area, just the surface area of its leaves and in its bark, about 100 gallons of water. If you extrapolate that over an acre, you're looking at about a ½ inch rainfall that can be stored before it's ever going to touch the ground. It can be stored in the canopy of the forest, and then again, slowly released. Some of it would drip down, of course, to the bottom. Others would just be evaporated back off of the trees, of the surface of the trees. So again, storage capacity being lost in the landscape. And then, of course, the addition of all the sediments that were now being sent into our river systems as a result of the exposure of the ground. So today we're around 20% forested. So we've recovered quite a bit of that, which is a good thing. And a lot of that 20%, a lot of that recovery is some of the worst soils that they weren't good for farming anyway. They were the ones that were just the economics of it. They were given back up and returned to forest. And then we move along to the area of moldboard plowing and heavy tillage of the soil. So this is a picture from Posey County from 1930s. And you can see, again, extensive erosion on these bare soils. Nothing was left. It was down right to the ditch, and soil just being eroded away every time the rains came. If you expose soil, every little raindrop on that loose soil, it's like a little bomb going off. When you look at it up close and you watch slow motion video footage of raindrops hitting bare soil, it just throws the dirt up and splashes it out. So all of that action is it's destroying the soil on the surface. This too is a result or results in a lack of storage capacity on our landscape. So we lose the wetlands, we lose the forest cover, and now we don't even have pasture on it. It's exposed soil, and when that soil is eroding, we're losing the organic matter in the soil. Organic matter in the soil is very important. Typical Indiana soils, when they were first busted, would have had about 6 to 8% organic matter. We're down to about 2 to 3% now. 1% of organic matter will hold an inch of water in the soil. So there's 5 inches of rainfall that's been storage capacity that's been lost in the soil. We lose it above the ground in the trees, we lose it on the ground in the wetlands, and now we're losing storage capacity in the soil itself. So all of this is going along and having a big impact on our river systems. This is another picture of field tiling. So this is another factor in what we're dealing with, what we're having to deal with. So these little pipes coming into the ditch are tiles that have been placed in the farm field. They create a network across the farm field. They bury these tiles about 2 feet deep, 2 or 3 feet deep, and it allows the water to leave the farm field sooner so that the farmer can get out and work the fields faster. You consider, especially like a year like this illustrates it well, the window, many summers and many springs, the window to get the crop on the ground in the field can be relatively narrow. And so these field tiles can be the difference between being able to farm it or not. And it's the same during harvest time. When they need to get the combine on the field, that window can be small. Field tiling helps to give you a little bit more grace, a little bit more window, because you can get the water off your field better, faster. But again, that's decreasing the storage capacity of our land. That water now is jutting off the field and into a ditch and down into the river much faster than it ever would have historically. And then the last factor in our history, around that same time, late 1800s, early 1900s, we had this phenomena going on: over-harvesting of mussels in our river systems. This is a picture from Vincennes, and this barge here, that's mussels.
My stars.
So this was occurring this is from 1905. The late 1800s, there was a freshwater mussel craze that went through the nation. So prospectors were out on all the Midwestern river systems. I'm sorry?
Yeah, and they make buttons out of their shells.
Yeah, it started with for the pearls, for the freshwater pearls, and then it moved from there to buttons. So when the pearls played out, that lasted about 10-15 years. When that played itself out, then it switched to button manufacturing. And so that carried on until the 1930s, when plastics began replacing the mussel shells for buttons. So our river systems were now handling way more water than they ever handled historically, which was washing nutrients out of the system. It was washing tons and tons and tons of sediment and soil off of the landscape and down into the river systems. And then we start losing mussels, which mussels are our natural filters in the river systems. So a single mussel can filter about 15 gallons of water a day. And so if you imagine an area of mussels 40 feet by 40 feet, which is probably about the size of this room roughly, that raft of mussels can filter about 30 million gallons of water a day. So how many 40 foot by 40 foot rafts run this barge on one day in one city along the Wabash. So we've never recovered this type of abundance in the Wabash River since, or any of our Midwestern rivers for that matter. That abundance has never been brought back. So our river systems are dramatically altered from what they were historically. It's easy to forget about that because it's in the water and we don't think about it. But fortunately, the Wabash is still holding its own for many species. And we'll talk about that in a second. So, I'm not finished painting a bad picture yet. Hang on. It's not all good. So, currently, more recently, we have this phenomenon going on, which is illustrated by this graphic. And I'll only focus on this top one up here. So what that 42 stands for is that's an increase in the intensity of rainfall events over that dark blue region, this upper Midwest region and Northeast. 42% increase since the 1950s in the intensity of our rainfall events. So that's defined as the top 1% of rainfall events. So these really heavy downpours. We're not so much getting more rain, although we have this year, but we're not so much getting more rain, we're just getting our rain in large, intense events. So again, intense rainfall events on a system that's no longer, doesn't have storage capacity any longer and can't hold on to the water. So how does that manifest itself? That shows up in graphics like this. So this is from the gauge right here in New Harmony. The top 15 floods since the year 1900, as measured by that gauge. This is 1990. Our flooding events are becoming more intense and more regular. And you can take a look at river gauges throughout Indiana, on the White River, on tributaries to the White, East Fork, West Fork, and you're going to see this same pattern repeated on all those river systems and tributaries. So it's a reality. It's just a new reality that we have to try to deal with and we have to try to cope with. And our river systems, so if you consider how a river works, I'm probably getting a little ahead of myself. I illustrate it better later on, but a river reaches an equilibrium. It wants to be in an equilibrium with the amount of sediment it's transporting. So it's going to erode a certain amount of sediment and deposit it further downstream. And it'll widen itself out to handle those peak flows. Those big intense rainfall events are what define the size of the river system, or a stream or a ditch or whatever. So with this intensification and the loss of storage capacity, our river systems, it's no wonder we're seeing the erosion issues that we are, and bank failures and so forth. It's because we've altered the landscape so dramatically, and we're seeing at the same time now we're getting this double punch with this change in climate and the change in the intensification of rainfall that's causing a lot more issues. So what's at stake in the Wabash? This is kind of where the Nature Conservancy entered in. 400 locations of known locations of rare species and natural communities. Despite the fact that we are intense in agriculture, Indiana and the Wabash River does still hold a lot of gems in terms of biodiversity. A lot of it has been spared. It's much reduced in range. As I mentioned with the mussels, there's still 75 mussel species in the Wabash River system. Many of those species used to be widespread. Now they're isolated in small tributaries here and there. The abundance is lost, but a lot of the individual species are still present. And 151 species of fish still present in the river system. And what we're going to look at now is the relationship between mussels and fish, and the relationship of that and the couple of facts I showed you right off the bat about connectivity to floodplains and lack of dams. So here's some of the mussel species. I like showing this because they have these great names that the early settlers gave to them. You can imagine the pistol grip and the keel splitter, how that might have gotten its name. But, and as I said, fish diversity and mussel diversity are intricately tied together in a river system. And this little video I'm going to show you here is going to illustrate that. That's going to take care of it. So what you're going to see here is this snuff box mussel. Again, one used to be common throughout the system. Now it's limited to the Tippecanoe River.
He's gonna grab it.
So it's kind of like waving out part of its mantle there, just doing its muscle thing. And here comes a fish along. And this fish thinks it's going to get a quick meal. And instead, the fish gets caught. Okay? So, what's happening now is this mussel is while it's holding that fish in place, it's releasing its larvae, its young, are being released into the mouth of that fish, and they're attaching to the gills. They will live as a parasite on the gills of that fish. Until they're mature enough, they'll drop off then later on and settle back into that gravel substrate that species likes, that species of mussel likes,
Do they
and
kill
live
the
out the
fish?
rest of their life. Pardon me?
Does it kill the fish?
No, it doesn't kill the fish. So the mussels have to have a fish to reproduce. And not only a fish, but a specific species of fish. Most mussels, many of the mussels, are host specific. If you lose the species of fish out of the river system, in time you're going to lose the mussel.
Oh my gosh.
And it's vice versa too. The mussels are important for keeping this substrate from being just silt, right? The mussels filter the water. The fish also prefer different types of substrate as habitat. If we lose the mussels, you'll start to lose the fish. You lose the fish, you'll start to lose the mussels. And so the Wabash has a good complement of both of them still in the river system. And so let's look at the fish here. This is where the Wabash really stands out compared to other Corn Belt Midwestern river systems. So again, the Wabash is right here in Indiana, and as you go from the pinks and greens and through the blue to the darker blues, that's an increasing percentage of fish that historically were present in each of those watersheds that are still present. So we still have the diversity in our river system in the Wabash largely that we had historically. And it's the same with mussels. And part of the reason we still have that diversity is because we don't have dams on the main channel of the river, or even many of our tributaries. And we're still connected to the floodplain by and large. So fish are migratory. When you put up dams and levees, you cut off those migratory corridors. So, yeah.
What does the green stand for?
It's just a lower percentage of the fish that were native to those systems that are still present.
In Lake Michigan?
Yeah. Yeah. So the Wabash stands out in these Midwestern river systems. And that's important for many large river specialists. There are fish species that's their habitat are large river systems. So in the Wabash, we still have things like this. Well, this is actually the East Fork of the White River, but it's a tributary in the Wabash. And when I speak the Wabash, I'm talking about the Basin.
Wow.
So this is a lake sturgeon. There are only 2 breeding populations of lake sturgeon left in the upper Mississippi Basin. And one of them is here on the East Fork of the White River. So a tremendous fish. This is another cool fish that we still have, paddlefish. And these are still fairly common, but they're of concern. Their numbers are declining rapidly, especially in other systems. And this fish in particular relies on that connectivity with the floodplain. It needs those backwater river areas, or the old oxbows, the old bends of the river. It needs those to complete its life cycle. It has to be able to move in and out of those systems and back into the main channel of the river system. So this is a species that we're concerned about. it's a good species for us to look at because it's still relatively abundant, and it's a good gauge of the health of the system. And then lastly,
Wow.
this guy. This is not from the Wabash. This is a picture taken in Louisiana. So these fish this is an alligator gar.
Ooh.
And they're more common as you go further south and down the Mississippi Basin. Indiana, the Wabash was always at the northern end of its range, but again, it's a large river species. So as the rivers get smaller, as you go closer to the headwaters, it's going to naturally fall out. In June of 2017, a bow fisherman on the White River speared one of these. It was the first alligator gar in over 100 years in the Wabash.
Wow.
So we're getting some things back as well. So this is a large ambush predator fish that should do really well given the Asian carp population that we have. You can see them getting to that size pretty quickly when you've got as many 20-pound Asian carp as you want to feed on. But just some of the cool larger fish that we still have in the Wabash system. There are many other fish species that are not quite as large and therefore not as splashy to put pictures of. That are those river specialists. That if we lose them we don't take care of our river system, we're going to lose them out of the Wabash too. So it's also not just about nature and the critters. It's also about people. As I said earlier at the beginning of the presentation, we all like to eat, and we want to see our farmers prosper. We want to see them doing well, being able to make a living while growing the food that we all like to eat. Clean water, of course, is important to everybody. Our goal, our task really is to find that common ground around those things, and clean water and a healthy, sustainable food system is part of that. So being the Nature Conservancy, when we take a look at how do we address these problems that we see, we're looking to nature to show us a way to fix that. I talked a lot about loss of storage capacity on the landscape, issues with the ditches and our river systems not being able to handle the volume of water that we're seeing. This is one way that we work in this space. So this is a ditch in Posey County I took a photograph of because it really illustrates what ag ditches want to do. They want to turn themselves into streams. Any ditch does. If you let it go, it's going to turn itself back into a stream. So this is a ditch that was built, and it was built undersized. Maybe when it was first built it was fine, but with intensification of rainfall, maybe some more tiling upstream of this, it's got more volume of water coming through it than what it could handle, than what it was sized for. And so what happens, you start getting the ditches, the banks eroding on the ditch, and they collapse in, and then you start to see it start to look more like a natural stream. It's widening itself out to create a new equilibrium, and you get these little benches that start to form, little floodplains on either side. And then in the bottom, this base flow, what we call the base flow of the river, or in this case the ditch, it starts to get a meander in it. And you got little islands. It's just a river in small scale, right? Typically what happens is they don't get this far along before they come through, dip them back out, pull all that dirt back up, throw it on the field, or reshape that bank and restart the clock again. And all that process, more so, it's just being transported downstream. So what we want to do is we want to try to jumpstart and design that natural stream function into the ditch itself from the beginning. So instead of going in and just dipping the thing out, well, let's redesign that ditch and let's create it in a relatively uniform fashion where we create benches purposefully on either side of that main base flow channel. You get little floodplains. When the water comes up in this, it has more room to spread out, so it's flowing slower. If you spread water out over a greater area, the flow and therefore its energy is decreased. And you now have vegetation that grows on these benches because most of the time it's not underwater, only when it rains. And so the vegetation also helps to slow the water. When you slow water down, it loses sediment. The sediments are tied up with the nutrients. The vegetation also can help take up the nutrients out of the system. The water leaving the ditch ends up cleaner than when it went into it. So that's a practice that we've been promoting and helping to get in place across the state of Indiana as a means to try to address some of that on the downstream side. And then things like drainage water management. So I mentioned the tile systems. This is simply just putting weirs in those tile systems. Before it enters into the ditch, you have a control structure that have boards that the farmer can go out and he can raise or lower the boards, and he can raise or lower the water table in his field. When he doesn't need to be on, there's no reason to let the tile run year round. Just back it up when you don't need to be on the field. Back the water up. You're going to have a better chance. Your crop's going to do better in those dry times in July and August if you've been able to store a little bit of that water on that field anyway. So just a common sense practice. It starts again to try to mimic and storage capacity, that lost storage capacity on the land itself. And then this is a big component that we've really been pushing on. And this gets to, so we start with the two-stage ditch, which is kind of the in-stream, the down stream end of it, the in-stream practice, the drainage water management, or those weir structures, which is kind of the edge of the field practice. And now this is the in-the-field practice that we're promoting. So what are the changes in the management system of in your cropping system that we can promote that will help to increase storage capacity of the soil, make your soil more resilient to those high water times, and then also to the drought times. So that's what soil health is. Traditionally, we've always focused on the physical aspects of the soil, its structure, clay, silt, the chemical components of the soil, so the nutrients that are in the soil. But increasingly, we're starting to appreciate and realize the biology of the soil and the importance of biology in helping to hold nutrients on the soil and also to increase that storage capacity and increase the productivity of the soil itself. So the aspects of soil health, essentially, it's a three-legged stool. It's continuous live cover on the ground. So when you're not growing a crop, you plant a cover crop to keep something growing on the soil. So the microbes in the soil, the life in the soil, has something growing in it, some life to feed on. Something that's going to fix sunlight, bring it down into the soil, and feed everything in the soil itself. Those microbes in the soil then feed the plants in turn. So the other component of that then is reduced, or better yet, no tillage. So when we go in, and it's gotten a lot better than the days of the moldboard plow, for sure. But when you go in and you disturb the soil, even a little bit of disturbance on the first inch or two of soil is where most of that microbial activity is occurring. When you disturb that soil, you completely disrupt that ecosystem that's in the soil. A lot of those soil microbes don't tolerate oxygen, for example. When you till that soil up and you turn it, you expose it to oxygen, so you completely alter the ecosystem. There are many fungi that live in our soils that help provide structure to the soil, and that structure also gets completely broken down by the disturbance to the soil. So it's continuous living cover and no tillage of the soil. And then the third component is good nutrient management. So when we put synthetic fertilizers and so forth on our soil, again, we're disrupting the natural ecology in the soil. So there's artificial, too much nitrogen in particular will kill a lot of the bacteria and the microbes that are in the soil. So those soils, those microbes and the continuous cover and the lack of tillage encourage organic matter growth in the soil. Remember I said we were around 6 to 8% in our soils. We're now down to 2 to 3%. In 10 years' time, now it varies a lot from one location to the next and from soil type to the next, but on average, in 10 years' time, if you no-till and you're cover cropping, you can add a percentage of organic matter in 10 years to your soil. So we can recover what we're losing just by changing our practices and doing things a little bit different. So we think soil health practices and promoting that, even though we're a conservation organization, we're about biodiversity, it seems like maybe a stretch, but we know that it's a means to the end, that we need to improve our water quality. Our landscape in Indiana in particular is dominated by row crop agriculture. We think it's a win-win for both the producer and for the environment. And there's a lot of farmers out there who've been doing these practices for a long time. I'll tell you the same thing. Their input costs are reduced. They don't spend as much on nitrogen or on fertilizers and on pesticides because they have a healthy ecosystem in their soil. They're in check and they're in balance. And their soils are resilient. So when the drought of 2012 came along, the long-term no-tillers and cover crop guys, yeah, their yields were down considerably, but they weren't a total loss either. So their soils were more resilient. And it's the same in the wet years. Because the soil has structure to it, you can get on and work that field much earlier than you can when it's being tilled. The soil just has structure to it, and it will support the weight of the equipment much more readily. So this is the kind of thing that we see all too often. You drive around during after heavy rainfall events, and we see this. This is soil running off of our field. This is what grows our food, and we're losing it. The end result is down in the Gulf of Mexico. So again, the Mississippi, and you can see the plume, the satellite imagery. You see the plume of sediment being discharged out into the Gulf of Mexico. So that's all soil that'll never grow another ear of corn. So it's more than just about the biodiversity and the animals and so forth that we're dedicated to. It's about all of the sustainability for all of us. How are we going to continue to feed ourselves and feed those additional billions of people unless we start addressing the loss of our ability to produce the food that we all enjoy eating. So one of the other, so this is just a picture of what a good no-till cover crop system looks like. So in this field, you see they've got, this is the fall, so they've harvested, you still see the corn stalks. They've planted their cover crop for the next year in these rows, and they've got some type of legume in here, some type of bean or pea plant, ryegrass, and then in between the rows, you still see the cover from the previous year's cover crop on here. So they're planting right into this stuff in the springtime. All that cover, there's no bare exposed soil. It's not tilled up and it's covered. So when rain hits that field, the energy of that raindrop is dissipated. Water coming off this field is running clear. Now, nutrient loss is another issue, especially nitrogen. Phosphorus is generally tied up with sediments. Nitrogen dissolves in water readily. So nitrogen is trickier to hold on to. The one slide I had, I didn't point it out, but the title was leaky soils. Nitrogen is tricky, but what we do know about nitrogen is that, again, as you increase soil organic matter in the soil, it better holds onto the nitrogen. And the cover crops, one of the big advantages to the farmer of cover crops is that when that corn comes off, there's typically nitrogen that's left over that didn't get used up by the corn. They paid for that nitrogen. It's on the field. The cover crop will come in and it'll tie that, it'll gather that nitrogen up to grow the plant. So it's going to hold that nitrogen all winter long until that cover crop is terminated in the springtime. And they'll either, most of the time it's sprayed, it's herbicide they'll use to kill it. But some of the guys, the more advanced guys, will plant right into it green, or they'll crimp it down. They'll just smash it down and just lay it down as it's a mulch essentially. So it provides weed control for them. But it's tying that nitrogen up, and then it'll slowly release it over the summer months back into the soil for the corn crop. So another thing I'll mention that we're doing that's new and that's exciting for us this year is right out the road here at the old bridge, we partnered with the USGS. There was already a gauge on the river. I showed you data from that gauge. Now that gauge is what they call a super gauge. So that gauge is gathering real time. It was up and running last year. I think it's not quite fully functional yet. They've had a lot of glitches. There was some vandalism a couple weeks ago to it. But that gauge, that super gauge, is now collecting real-time data on not just the river levels and flow, but it's also collecting nitrogen, phosphorus, and turbidity levels. So all that information is telling us then, so that the data I showed you with the Wabash being 20%, all that information is based off of models because we don't have good enough real-time data to give a real estimate. So we go and we do periodic sampling, and then you model it to determine what the overall amount is. As you can guess, that's not very satisfactory for people, especially regulatory and ag industry and so forth, when you're wanting to make big changes, right? They want real numbers, they want to know and have confidence in that. So one of the ways to do that, we needed a gauge at the mouth of the Wabash that's going to tell us exactly what's coming out of the Wabash. So we all can agree on these numbers, and we can all get on the same page. So last year we partnered with the U.S. Geological Survey that runs those super gauges. We got funding from the Walton Family Foundation. We got funding from Purina Nestle to help install that gauge and get that gauge up and running. So now we have the ability to get much better data on what's coming out of the Wabash and hopefully get better agreement and better partnering among the various agencies and commodity groups. And the commodity groups they're at the table. They want to solve this problem too because they understand the implications of it, and and as I said, we can all agree we all want clean water, and our river systems. There's no doubt that our river systems are not nearly as good as they used to be. So I like this quote here because it really gets to that fact about the Wabash being connected to its floodplain. And so this guy's saying protect as much of it as we can while we can. And so we've been doing that. We've been working with NRCS. This is another component of that, using nature to clean our water. Our floodplains are our last chance to clean the water before it leaves us. It goes on downstream. Once it's run off the land, it's already in the river system. We have these flood events, that water gets out on the floodplain, just like in that little two-stage ditch. It spreads out, it slows down, sediments are deposited out of the water, nutrients are taken up out of the system, and our floodplains are doing that. So across the floodplain down in this part of the state, our floodplain's about 8 miles wide. As you all are familiar, it's a vast area. When this floods out, it's a vast area of water. Each of those acres of floodplain can filter about 60 pounds of nitrogen, 600 pounds of phosphorus, 17,000 pounds of sediment. So there's a tremendous capacity of floodplains to help clean the water. And so we've worked over the past 40 years now with the NRCS to promote easement acquisitions in the floodplain. So where we have these marginal farm acres, they're flooding too frequent to make a profit on them, let's put those into an easement program, let the vegetation grow back on those, And instead of being a contributor to sediments and nutrients in the system, those are now helping to take those things out. So we've got about, across the Wabash, that's these red areas, those are the easements up the main channel of the Wabash. We have about 44,000 acres to date in floodplain.
Is that vacant land easements? Is that what they call it?
It's the Wetland Reserve Program is what it's called. Yeah. And so the owner still owns, they still own the title to the land. It's just a permanent deed restriction that doesn't allow for any development or farming any longer on that property. They can still hunt on it, they can do hunting leases on it. So we get those benefits for nutrient reduction, and we also get habitat creation for wildlife along in the system. So multiple benefits of nutrient or floodplain reforestation, nutrient reduction, the habitat, and the flood risk reduction as well. When we spread that water out, the further upstream we spread that water out, the longer it takes to get downstream. So it gives the system more time to clear itself out, as opposed to being a big flood of water that then overwhelms cities and towns and people. So, and then lastly, their carbon sequestration. So reforestation is probably studies have shown reforestation is the cheapest and the best way to sequester carbon. Floodplains in particular are really good at that because the trees go very, very fast. So this is a picture here down from Mackey Bend, just downstream from here. This is about 10 years worth of tree growth, and we got 20-foot tall cottonwoods already. So that's all carbon now that's tied up in trees. So floodplains we think are a great option, and we've been exploring ways that we can ramp that up. Our strategy up to get even more acres. You know, our mission to protect the lands and waters which all life depends. So that's TNC's mission. That's what's really driving us in the Wabash River. And as I've said, it's healthier habitat for plants, for animals, but also for people. So that's largely what I'm involved in. That's what the Nature Conservancy is about. And I'd be happy to answer any questions you have.
Have you ever heard of the community using ditches that you described?
Two-stage ditches? The two-stage ditch?
Yeah, the two-stage ditch. Have you ever heard of a community using a two-stage ditch as a means to improve its ability to fight off a flood?
Within a community as part of like stormwater management?
I mean, yeah, like here, for example.
No, I have not. We promote the strategy in ag ditches. I have heard of much larger ditches being designed into what they're calling a two-stage ditch, but so that strategy was really designed as an ag ditch strategy and the reason was because of the cost. Moving dirt is expensive. And as you increase the size of the ditch, or the water body that you're trying to manage, the size of the bench that you need to create, the amount of dirt that needs to be moved starts to get exponentially greater, which starts to rapidly increase the cost of the strategy. The concept, though, however, would certainly work. I mean, it widens the ditch. The ditch has greater storage capacity. And we do know that water is attenuated. It's held longer. The flood peak is lower in those areas immediately around that ditch.
Well, it seems like it would.
Yeah.
And then upstream from here, is the Nature Conservancy doing anything with floodplains, like planting trees and some of the things you showed? Is that upstream from here or downstream?
Well, both upstream and downstream. We have a project, a partnership with the NRCS. We're going to be applying to renew that partnership. Hopefully we'll get additional funding for that. The current one ends in this year, 2019, where we're partnering with them. We provide some restoration dollars, and they provide the dollars to actually acquire the easements. But even it's up to the landowner whether they want to do active restoration on those easement acres or not. Most people opt not to do any type of active restoration. They're done with it. They just let it grow up, which is fine. They grow up very quickly. They're not as diverse. It's not as good a habitat as if you do an active restoration. But in terms of carbon sequestration, nutrient reduction, most of those benefits, if you just let it grow up, it'll do all those things really well. So I don't know if that answers your question.
Well, with that, would there be any way to show whether those interventions would make a change in the amount of water that flows by here in the marsh?
Yeah, that's a multi-million-dollar question because that's a very expensive. What we've been told is that that's very expensive study to undertake. That's a tricky question to try to answer. We know that as we reconnect floodplains in particular, if you give the river more space, it's going to hold more water, which is going to slow things. And so we know the Corps of Engineers does that on the Mississippi, right? They have flood easements. When the river floods out and gets above a certain stage, they literally blow up the levees and allow the water to go out onto those floodplains. And they can drop the level, it was 2011, I think, in Cairo. They dropped the water of the Mississippi in Cairo 1 foot in a matter of hours by doing that. So we know that works, but how much it works and how much it would take to get it to work, I think that requires a large hydrologic study to achieve that. So I think, from our perspective, we don't make claims about how much flood protection we can get out of this. I think we're just now at the point where we can start to make claims about how much nutrient reduction we can get. The science for that is a little bit better, a little bit easier to calculate than the issue of hydrology. So, yeah. Other questions? Yes. Yeah.
Has there ever been any effort to recover the lost sediment?
To recover the lost sediments?
Yeah. It's a commodity.
Well, certainly in ditches, if you do a ditch, there's no shortage of farmers who will take that dirt out of the ditch. Mostly it goes right back on their own fields, but we did a 2-stage in Spencer County where all the dirt that came out of that ditch got hauled away to somebody else to put on their fields. We have Ray McCormick, he's a farmer in Knox County, he's on our board trustees. He likes to tell a story of, he's a no-tiller and cover crop guy and farms a lot in the floodplain, and he likes to joke about how he appreciates the sediments that his northern neighbors are giving him. So he has pictures of his cover crops in his fields, just coated with dirt, and he's had, taken samples of it, had it analyzed, and it's good high nutrient dirt. So for him, that's a win. The challenge for him is the flooding issue. He still has to the field still has to stay dry long enough to get the corn crop to go without killing the corn crop. And that's been a challenge on the Lower White in particular. The Lower White River has been hit really, really hard with flooding. And it's just, over the last 10, 15 years, it's just nonstop almost every year.
So if we promoted hybrids that had shorter growing seasons, there'd be less need to tile fields because you wouldn't have to get in them. So is there a way to do that? I mean, does that make sense?
Yeah, so that's beyond my realm of expertise, hybrid corms and what the options are. But I think what I do know is guys, long-term no-till cover crop guys, soil health guys, will tell you that because their soils are as healthy as they are, they're porous, they have air pockets naturally through the worm channels and bugs and roots, and their soil is like a sponge, yet it is not soft. It is firm, it has structure. And I've heard it called, the poor man's tile, field tile, because their field is workable when other fields aren't. Yet it's actually holding more water, but it's more workable.
Are these concepts taught at Purdue and any other university that teaches agriculture? Do you speak at these institutions?
We partner a lot with Purdue and researchers at Purdue. I think there are some challenges there in the research institutes. They're certainly involved in the research behind a lot of this stuff. I think most of the promotion of this stuff is through outside organizations. But the research institutes are certainly coming along.
So why aren't some of these things legislated? For instance, more buffer, riparian buffer along rivers and streams to avoid runoff. And some of these concepts, do you ever see it? I don't think it's going to happen in the next few years. But when is this going to be legislated, if ever?
Well, within the states, the Corn Belt states, I'd say that's a political non-starter. And the ag industry itself is very conscious of the fact that the Gulf hypoxia zone has brought a lot of attention to the Midwest. And now, because the Wabash is number one, it's brought a lot of attention to the Wabash. They don't want that attention. And they're aware that with that attention is the threat of regulation. So the Chesapeake Bay has gone through that. They went the regulatory route. And they've been trying to address that through regulation to try to clean up the bay. They've made some progress, but progress has not been real fast, and nobody's really happy with it. So I think the hope is that we can do this in a way that we can avoid that type of the regulatory approach, and regulations are it's difficult to get regulations to be flexible, and farming systems it's different from one guy to the next, and even on the same soil type, let alone different soil types. And it varies. Every person is different, and every one of these, even the long-term no-tillers and cover crop, they all do it differently. They all have a different system that they work. So what works for one guy is not going to work for the next guy. And so, I think the hope is that we could avoid that, but I think that has brought, the threat of that has certainly brought the industry more to the table, and it's gotten their attention, and they're being good faith partners in trying to figure this out, trying to address this. Ultimately, the decisions are in the hands of the individuals, the individual producers, and how they're managing their operations, and change is difficult. You're adding a whole lot more variables into your system when you're going into a no-till and cover crop management system. It takes time to learn that and figure it out. And when you've got to make the bank payment in the fall, how much are you going to risk? When I'm pretty sure I can get that 200 bushel, but if I change my system a little bit, I don't know if I can or not. So it's hard.
One more question.
Yeah.
During these runoff events and just loss of soil for erosion, what kind of particle size distribution changes happen in a soil? So does sand, silt, or clay run off more or less, or is it an equal loss of the three particle sizes?
Boy, that's a good question.
And I'll tell you why I ask.
Yeah.
Right? So when I get dirt for what I do, sometimes I will get pure clay. It's got to be pure clay. I've never done the particle size distribution. I'll get truckloads of sand, mix it up. But I've often wondered, how can you go to one field? It's pure clay. And I don't think it's just, I think it's a man-made problem. There are sandy soils, of course, or clay soils, of course. But it's just amazing to me how large swaths of land can just be pure clay.
Right.
I just wondered if man is part of that, or if that's just the way it is.
No, I would say so intuitively it makes sense, right? The smaller, finer sand particles are going to come off first. And I would say that the topsoil itself, we know we've lost topsoil. That's what's coming off first, right? underneath that topsoil in the Midwest is the clay. Now, sometimes that clay is mixed in well with the topsoil, but in this highly erodible soils, we've lost, in some places, we've lost almost all the topsoil. So all you have left underneath there is the clay.
So if I look at Posey County where I've
Yeah.
walked, the topsoil is gone.
Yep.
Is that fair to say?
Well, so in some areas I would say yes, it's fair to say. I'd say most areas we've not lost all of our topsoil, not yet. But we are at soil loss rates that are not sustainable in most of our ground. So it's not sustainable. We can't keep losing our soil at the rate we're losing it and expect to continue to get 200 bushel corn off of it.
You mentioned the Asian carp. I'm wondering if you could comment on invasive species. Are they getting worse? Or are they better? What kind of problem are they causing?
Yeah, I don't know carp, specific to carp, I don't know that their numbers are necessarily getting worse. They're already really bad. The carp are an artifact, too, of the nutrient problem. The carp are planktivores. And the plankton are what's living on all this excess nutrient we've got in the system. It's driving tremendous blooms of this stuff. So we've created an environment that's like super, it's like an all-you-can-eat buffet on a cruise ship. It's just, it's gluttony. And so the carp, they're not native to here, but it's a symptom of the nutrient problem. And I wonder, and I've asked some researchers this and kind of puzzle about it. I've not gotten any real answer, but I kind of wonder, it's like, well, should we be thankful we have the carp? If we didn't have the carp, how much dirtier would our water be? If we didn't have the carp, we eating all this plankton up and accumulating it in their biomass. We've seen the benefit to bald eagles. I mentioned the alligator gar. So lots of stuff feeding on all that carp, all that abundance that we've created in the system. So they are a huge annoyance, and they're no doubt changing they've changed the ecology of the river systems. But that's not, you can't separate that from the whole nutrient issue. So
I would just like to know what that first picture is when.
That's from the northern part of the Wabash, the upper reaches. The very first slide?
No, what that you had on before it all started.
The beach picture.
The beach picture.
I know what
The one not of the Wabash.
Screensaver.
Oh, the screensaver. This is not my computer. Yeah, that's not the Wabash. That's not me running.
Just curious.
Yeah, I don't know.
For what it's worth, she asked me beforehand. I looked it up, and it's Wawariki Beach in New Zealand.
Oh, I haven't been there.
It's your
Ooh,
trivia fact for today.
it's beautiful, thank you.
Any other questions? Well, this is just a small gift from the friends. Thank you so much for coming out here and sharing your information with us. It was a lot to think about. And let's just give them another round.